So in this lecture, we will be answering the question, how can I choose hyperparameters? Now please note that while I've discussed this in the course already, sometimes people forget. So I'm making this lecture to explicitly remind you of this topic. Now this is often a point of frustration amongst those who are new to machine learning. It is natural to feel like there must be some direct method of doing this. They think because this is science, that there must be an answer, that there must be some formula or some algorithm that will yield the correct result. Unfortunately, this is not the case. And if you want to succeed in machine learning, you must be comfortable with this reality. As a side note, some have said that machine learning is more like alchemy than science. I would tend to agree with this notion, and this is one of those areas that makes it apparent. So before we continue on, I want to mention that this applies to all the hyperparameters discussed in this course. For example, in the early parts of the course, our main concern is, how do we choose the learning rate? What is the best optimizer? In the ANN section, our concerns may be, how do we choose the number of hidden layers? How do we choose the number of hidden units? How do we choose the best activation? What dropout probability should I use? In the CNN section, our concerns may be, what is the best filter size? What is the best number of feature maps? And these general themes repeat throughout, as you learn about RNNs, NLP, recommenders, GANs, and so forth. So please keep in mind that this is not actually a separate question for each of these items. These are all actually the same question. Specifically, it's the question of how to choose hyperparameters. So the answer to this question, although many of you may find this disappointing, is my famous rule: machine learning is experimentation, not philosophy. The problem is, many beginners start to look for deep philosophical reasons for choosing this number of hidden layers or that number of hidden units. In fact, the correct answer is to simply try random values and see what result you get. Obviously, the final choice should be the one that gives you the best results. The basic idea is that you must do experiments. There is simply no other option. One obvious thing you can do, if you want to be sure you're at least in the right range, is to look up the papers in your field to see what they used. This is assuming that your datasets are similar. So that should give you a reasonable starting point for your random search. But do keep in mind that this adds a bias and could potentially prevent you from searching closer to the optimal point. This will also help you get a sense for the scales at which to try random values. For example, learning rates and many other parameters are usually chosen on a log scale. For example, 0.1, 0.01, 0.001, and so forth. If you're interested in seeing more specifics, including actual code, to run a random search, I've already covered this in my in-depth series of deep learning courses, specifically modern deep learning in Python. Do note, however, that most of it is just common sense. For example, if a value of 10 is bad and 100 is worse, and 1000 is even worse, you probably won't continue on in that direction. It may help if you made a plot of your model's performance versus the hyperparameter value. But again, this type of thing is just common sense. Now, many beginners still object to this. They say, but lazy programmer, there must be some rules of thumb. Why can't you just give me some simple rules of thumb? And the answer to that is, this is simply a bad approach. I'll illustrate this with several examples. As you recall, we've noted that Atom is often the default choice for optimization method. However, there was a paper that came out showing that plain SGD performed better. Thus, if you're the type of student that tries to follow only rules of thumb without actually doing the requisite work, you may have landed at a suboptimal result. This is what happens when you fail to experiment. Here's another very recent example from OpenAI, released in October 2021. In this paper called Grokking, the authors explore an interesting phenomenon regarding the ability of neural networks to generalize. Now, the idea behind this paper is not that relevant for this discussion, but what is relevant is what the authors tried. Specifically, they tried different approaches, such as full versus stochastic gradient descent. They tried different learning rates. They tried dropout. and they even tried weight decay, which is a method that has somewhat fallen out of favor in the modern era of deep learning. So even researchers at one of the top AI companies in the world still must do these experiments, and even on simple things like weight decay. Furthermore, I lied a little bit when I said the idea behind this paper is not relevant for this discussion. In fact, what the paper demonstrates is that reality disagrees with some long-held notions about statistical learning. Specifically, they show that neural networks can in fact generalize well if you keep training beyond the point it has overfitted. So again, if you're the type of student that just wants to memorize some rules of thumb, you would again be proven wrong by those who did the actual experiments. Importantly, you should expect things to constantly change. You should expect any rules of thumb you've memorized to soon become irrelevant. Put more simply, memorization bad, experimentation good.